Hi there. My name's Cail. I am a senior SRE at Octopus Deploy, where I work in a team that we look after our build and test and delivery infrastructure in order to get our product out to all of our wonderful customers. Why do this talk? I've discovered over the last little while that there's tons of material out there for continuous delivery for applications, but actually not a whole lot for infrastructure that runs those applications. So I thought, look, let's put something together and I can sort of share some of the things we've learned over the last little while. To talk about what we're going to go through today, I'm going to just define some terms. What do I mean by CD? I'm going to give you a little history lesson of where we started when I joined the company in terms of the platform that I help run today. Then we're going to get into, all right, well, how do you do CD for infrastructure? In particular, what do you do when you can't interrupt workloads easily, which is a big challenge for us? And then finally, like, how do you test changes? So what do I mean by CD? Do I mean continuous deployment, continuous delivery, continuous dishwashing? I mean continuous delivery. And I'm going to just put a quote up here from Jez Humble. I'm not going to read that whole thing out, but the stuff I put in bold there is kind of important. We need to be able to make changes safely, quickly, but also in a way that's sustainable for the team. That's really important. So, a history lesson. I've been working at Octopus now for about 4 years, and I'm going to go back to kind of 2021 and look at the way things were in low detail for the build and test and delivery platform. We had a single CI server on a single VM that was a kind of what I'm going to say click-opsed into production. We had no infra as code describing it. And then outside of that, we had some manually created blob storage accounts. We had a manually created Artifactory set up doing some artifact handling inside a somewhat infra as coded AKS cluster. And then we had some agent compute running in ephemeral VMs that were described with Packer, which is an automation tool for building VM images. But the infrastructure those VMs ran in was, again, manually created. Now, you might be looking at that and saying, well, that looks really nice and high tech. Like, what's so bad with that? Well, one of the first things that I experienced in this team was making what I thought was a routine change, and then accidentally restarting that Artifactory instance I mentioned. And at the scale we're at, restarting Artifactory is a multiple minutes kind of affair. And lots of our platform depends on Artifactory being available, it turns out. It's kind of not a good look when your team is like, whoops, sorry, took down everyone's builds for half the day, or at least it felt like that at the time. So we thought in response to this, well, let's be careful. Let's only do these kinds of changes kind of at the edges of working hours. But that only works so far. That's fine if you do that once in a while. But the more we kind of took on this platform, we're like trying to patch third-party applications. We're trying to make improvements to the way our agent compute works. That's a lot for a small team where pretty much every week someone is having to draw the short straw and go work outside of their normal working hours. It kind of leads to this problem of, well, I didn't sign up for that. I didn't sign up to be working out of my normal hours constantly. You know, I have commitments outside of work. This leads to burnout potentially, people wanting to leave the team or leave the company. Now, this seems kind of intractable, right? Like, okay, how do you get out of that hole? What do you do? Let's talk about CD for infra. And rather than throwing like a big architectural diagram at you with the way things are right now, because I don't think that's not going to be helpful for your context necessarily, I'm going to step through some of the properties of the system we've ended up with that I think improve on the old way in a way that might be useful for you. Just before I do, though, I need to just mention most of the advice that's coming up here is going to assume that you're running on virtualizable machines, not bare metal. You know, I don't think I'm going to say anything that means you have to be running in the cloud. Most of this should work if you have like a private cloud setup. But bare metal, I can't speak to. Maybe it'll work, maybe it won't. I am also going to use some terms from Terraform, which like plan and apply. That's just because that's mostly how we work with many of these things. But I think the patterns I'm going to talk about should work with any kind of infra as code tool that you might want to use. So speaking of infra as code, I think this is foundational for CD for infra. You can't really do this without having a way to describe your infrastructure stack programmatically. You can pick any technology. We use Terraform, but I think you can use anything. Doing this might be the slowest part of this journey. If you're not already using infra as code, this might be the single slowest part of getting to this wonderful CD future. Even if it's hard, I think you should do it. We had to move that single instance CI server from its kind of snowflake clicked into existence VM. And we took that as an opportunity to rebuild using infra as code. It took us a long time because there was a lot of things we hadn't anticipated. There was a lot of things we had to glue together. But in the end, we ended up with a full production infrastructure stack described in Terraform that we could then stamp out and use in other environments and make changes too quickly, and all of the benefits we're going to talk about. It's worth doing. So once you've got the basics of infra as code, the next thing that you need to be thinking about is what I'm going to call environmental progression. So you take this code that represents your production environment and you use it to also create your pre-production environments. There's a few different ways to do this. One way that our team uses is to use Octopus Deploy, although you could use other tools, to inject what I'm going to call scoped variable values. So your infra as code will have little tokens in there. One good time that you would use this is if you want to use like large VMs in production, but smaller VMs in pre-production. So you can have a single config file that then at deployment time, when the pipeline runs, put different values in there. Beyond that, if you want different ways to think about different ways to represent this in your actual files, the simplest way is just to have production and all the pre-production environments be the same, other than maybe those variable changes. But I do know that other organizations take this approach of, well, let's have a folder per environment in our repository. So you have one for production, then you have one for pre-production, one for QA, one for staging. This works better if you've got larger differences between your environments than simple variable changes could possibly describe. And for a hard mode, you might want to use something like a code generator. Now, in Terraform land, that's a tool like TerraGrunt, which kind of merges these two ideas together. You have a single set of files that kind of describes most of your stack, and then another set that describes the way in which each environment differs, and it saves a lot of copy pasting. But there's really only value in doing that if you've got very divergent and very numerous pre-production environments. For what it's worth, we tend to use that first one. We tend to just use a single description with some variable injection. It makes onboarding really simple because we just say that's the infrastructure for this service. So once you've got progression set up, what do you do with that? Well, I'm going to say your pipeline should be automatically deploying any proposed change somewhere. Now, if this is a brand new service, maybe you're going to be deploying this straight to production. YOLO is a term we use. You only live once, kind of take a bunch of risks. If you're not actually using a production environment yet, feel free to just go send stuff straight there. Commit and ship, commit and ship, commit and ship. That's fine. But if you're beyond that, depending on how you've set up your pipeline, folder per environment or whatever, you've got to have your deployment pipeline choose what to deploy where. And this affects how you apply changes as well. I'm also going to say, if you are deploying to pre-production, your pipeline should be automatically planning, which is a Terraform term, but giving you some kind of indication of what's going to happen when this change goes to production. In our case, we use Terraform. We get out a plan that says, okay, here's what I'm going to do when I deploy to production. And a human needs to go look at that and say, yes, this makes sense. If you are deploying to production, at least in the beginning, strongly consider setting up your pipeline to stop in between that plan set stage and the apply stage and have a human look at it and go, okay, it's going to change this, it's going to add this, it's going to delete and recreate that. Do I want it to do that? What effect is that going to have? Very valuable, at least early on, before you've kind of got a sense of what sort of changes might cause what sorts of impacts. Now, everything up to here is pretty much enough if you're running replicated stateless services that can be interrupted during gradual rollout of infrastructure change. But what if you aren't? And as I said before, I work in a team that manages compute resources for builds and tests, and these are weird shaped workloads. They need heaps of compute for a short amount of time. They have tons of state they have to write down and do interactions with. And they often run for a really long time, and there's only one of them, and if they get interrupted, people get angry. This is the reason why we were doing so many out-of-hours changes, because our software engineers didn't want these long-running tests to get interrupted. So what did we do? What do you do with uninterruptible workloads? I've got some bad news potentially. This is going to require you to talk to some people, assuming that those workloads are actually important to teams outside of your own. I want to introduce you to the idea of mechanical sympathy. What I mean here is go out there and build a deep understanding of exactly what's going to happen when an interruption happens. In our case, our CI system actually automatically restarts. So it's not so bad, but it just means some lost time. And go build an understanding of what you can get away with in terms of downtime or reduced capacity. And then and only then start to form your platform around, okay, what are people actually expecting of us? Some ways this might play out are, what controls can you put around unacceptable termination? So maybe some termination's okay, but not all of it. If you're running in Kubernetes, we, for example, pod disruption budgets to say, okay, we want these things to never be interrupted. We want these things to be only partially interrupted during upgrades, things like that. And as I said, you're going out and doing the legwork to figure out, okay, what am I allowed to make unavailable? What am I allowed to degrade the service? So once you've developed this sense of mechanical sympathy, what kind of infrastructure choices could you be making to enable continuous delivery? The simplest way I can put this is you need to start with two. Two of what? Well, in Kubernetes, there might be node pools. In something like Azure App Service, there might be app deployment slots. I think it's a lot harder to migrate a deployment pipeline from one thing to two things than it is to go from two to more than two, because it changes how you think about, is this a list of things or is this a single thing? To start with two, because if you start with two, you can do things like use the expand contract pattern, where when you want to make a change, just add a new thing of the thing, send some traffic there, and then remove the old one. Or you can use blue-green, where if you want to try something, you can temporarily make a change to part of your system, see how it behaves, and then either commit the whole change or roll it back. Now, I said something before that's worth just leaning into a bit. You're going to need some way to manage traffic. And I don't just mean web traffic here. We've got a service that depends on the ability to create and manage pods in a Kubernetes cluster. And yeah, look, I mean, under the hood, that might be HTTP, but we're not using like a reverse proxy to do traffic management here. We have some other custom stuff we've written to say, okay, take that work and send it over to this set of node pools instead while we're making changes over here. It's critical for you to be able to make changes safely without anybody noticing. So, all right, you got your pipeline up and running. You need a way to be able to use the advantages of CD here, which is where you can test changes before you actually commit to putting them into production. And there's two kinds of things to test here. One is, will this infrastructure change actually deploy? Can I roll it out at all? And then two, if I have rolled it out, does the change actually have the effect that I want? There's a couple of ways to do this. The first is to have long-lived pre-production environments, and I think this is pretty common in most organizations. And you would test your changes in one of them, and then promote them, if you like, to your production environment. If you're finding though that your team or teams are kind of fighting over these pre-production environments, you might need to consider ephemeral pre-production environments where your pipeline actually will stand up a new set of infrastructure just to test the change you're proposing to production. Now, there's some patterns to actually run these tests. The simplest one, and one that we use for a lot of services, is you deploy the whole change to a pre-production environment when you open a pull request, but also, as I mentioned earlier, run that planning as production, show you what that's going to look like, and then merge the change into production, deploy the change into production once you've merged. There's a hard mode here where if you're finding that every once in a while these PRs work fine in pre-production, but then when you deploy to production, don't work. Where you begin with deploying the production infrastructure into pre-prod, and then deploy the entire proposed change. And you only really need to do this if you're finding that individual commits deploy okay, but then the whole set of them combined don't. Because there are some infrastructure changes that work okay in a sequence, but don't work okay when you do them simultaneously. It's just the nature of the beast, unfortunately. So that's a lot of information. Let me try and bring it back to something you can kind of take away from this. Yes, you can apply CD to the infrastructure, even if the work is uninterruptible. We do it all the time. We're very happy with it. And there are two things you need to remember. Ironically, start with two. It's a lot easier to go from two to more than two. And try to develop some mechanical sympathy. Understand who uses your platform, what they use it for, and how that work behaves when it gets interrupted. Thank you so much for your time. Questions are welcome. If you want to reach me, that's my LinkedIn link there. Thank you so much.